Okay, so we've got a factorization problem here where we're asked to do a complete factorization of what turns out to be a four-term polynomial. And when you look over a factorization situation, anytime you're asked to do any kind of general factorization, you just want to check first to see if there's a greatest common factor you can get out of everything. So here, when you look things over, there's no meaningful greatest common factor that simultaneously can come out of a 10, an 8, a 35, and a 28. So there's no numeric GCF involved here. And as you can see here, this doesn't have x in it, and this doesn't have y in it. So there's no common factor in terms of variable pieces that you can pull out from all the terms simultaneously either. So since there's no GCF, you go into looking for some other kind of technique, and it turns out that this particular polynomial is set up to run with factoring by grouping. Factoring by grouping is often a convenient approach where you have a polynomial with an even number of terms greater than or equal to 4, and in fact we have precisely 4 here, 1, 2, 3, 4. So a reasonable thing to try when you run grouping with a polynomial with an even number of terms 4 or more is to just split it in halves, split it in two pieces. You can't get an overall GCF out of everything simultaneously, so actually literally split it up into two halves and see then what you can do in terms of getting little greatest common factorizations out of each little subgroup. So when you look at just this first grouping of two terms here, the two leading terms, now there is a greatest common factor that you can pull out of just that little half there. You can get a 2 and an x squared simultaneously out of both of those terms. That leaves behind a 5x and a minus 4y. And with that completed little greatest common factorization on the first group, now move on to the second group, treat that as now its own little separate polynomial, and try to run a greatest common factorization on it. And you'll have a successful grouping if this exact same leftover polynomial piece, 5x minus 4y, is left behind. Then you can actually finish things off by a binomial greatest common factor approach. So when you look at this minus 35xy plus 28y squared, treating it as its own little polynomial, it has a leading negative, so you know at least the leading negative is going to come out. And then when you look over the rest of the terms, you can see that you can commonly get a 7 out of both of the coefficients and then a single factor of y. So when you pull that 7y greatest common factor out, that leaves behind a 5x and then minus a 4y. So there's the key. This is the signal for a successful grouping. When you have exactly the same leftover polynomial piece remaining from each of the little greatest common factorizations you've done, that means the grouping's been successful, because now you have a multi-term greatest common factor appearing in both of the two big terms you've created by grouping things up into two halves and then doing two little greatest common factorizations. So now you can see now 5x minus 4y is here, 5x minus 4y is here, so it then is a greatest common factor. You can then factor it out of both of those terms, so there's that 5x minus 4y coming out there. And then to finish off the factorization, just as with any greatest common factorization, now write out what's left behind when you take that GCF out. We took out 5x minus 4y, so from this term that leaves behind a 2x squared, and then from this term that leaves behind a minus 7y. So then, of course, when you finish a stage of your factorization, and this now is complete, the grouping has been successful. We took out the greatest common polynomial factor that resulted from that grouping, and we wrote out what was left over. Now that the grouping's successful, you just check to see if there's anything else you could do. But when you look at this is just a linear factor. There's nothing else you could do with this. And this, well, it's not a linear factor, but it's really nothing that's factorable over integers with the techniques that we've got. It's not a difference of squares, it's not a sum of cubes, difference of cubes, certainly no more GCFs or grouping or trinomial possibilities in this. So there it is. Once you finish off the grouping with this one, there's your final answer, 5x minus 4y times 2x squared minus 7y.